Hey guys, in this video we're going to talk about an abstract data structure called a stack. And an abstract data structure is just a neat way that you can organize your data. So how does a stack work? Well, think of it like stacking plates. Maybe you're done with dinner, you finish washing your dishes, and it's time to put away your plates. When you put your first plate, you put it at the bottom, and then the next plate you put on the top of the bottom. And as you keep stacking it, every time you add a new plate, you put it at the top of the stack. And this is how the stack data structure works. The first item in the stack is always at the bottom. The last item you always put on the top. When you want to add data, you always add to the top of your data structure. However, when you're removing data, you're going to remove from the top. I don't know about you, but when I take plates off of the stack, I always take them off the top. So the stack data structure works the same. So because of this, it has something called the LIFO property, which means that the last in is going to be the first out. And with that being said, stacks can be implemented with a linked list or a dynamically allocated array. And in these next series of videos, I'm actually going to take the harder route and I'm going to create a stack using a dynamically allocated array. So why don't we move on and look at an example with how we go about adding data to a stack. So let's say I have something empty and I want to add the number 1 to it. I would place it onto the stack and it would become both the bottom and the top. So if I want to add the number 2, let's say for example, I'm going to add it on top of number 1. And the same thing if I want to add, let's say, a number 8, and then if I want to add a number 5. And this is a nice way to visualize adding data to the stack. But when I want to remove it, I'm going to be removing the 5 first. So it was the last one that was added, and it's going to be the first one that's going to be removed. So if I want to keep removing, let's say I want to get rid of 8, I would do it this way. However, if I just wanted to remove 2 but not 8, I would have to remove 8 from the stack, store it somewhere else, remove 2, and then add 8 back. But in the end, if I just wanted to remove 8, I'd be left with this data structure. And this is a quick overview on how stacks work. And in the next video, I'm going to go and create my stack class, and I'm going to be creating it using a dynamically allocated array. And with using a dynamically allocated array, as I add and remove from the stack, I'm going to be making sure that the last element is what's the added value, or the last element is what's going to be removed. Anyways, I'll see you in the next video.